So we're going to start section 5.7a, and it actually has a different title than this, but I changed the title because we could solve pretty much all polynomial equations by graphing, right? Or at least get some answers. Well, not always, but most of the time we could at least get some answers. Let's jump right into the notes. Let's begin with the fact that the roots, the zeros, the x-intercepts, the solutions, they're all answers. We need to solve this. So one option is to actually get on Desmos and graph it, okay? And let's do that. Let's go to Desmos. You could, if you wanted to, type in y equals x to the fifth minus 81x. Don't put the equal 0, right? You could type in y equals, or you could just type this in, x to the fifth minus 81x, and it'll graph it for you. And remember, the solutions are the x-intercepts. So if you see that your graph crosses the x-axis at certain locations, then those are actual real answers. So let's go to Desmos, type it in, and let's see where it crosses. Hopefully you typed it in the way I did. And you could zoom in, zoom out accordingly, so you could actually see all the different x-intercepts. And if you click on the x-intercepts, it'll actually give you the precise location. So this tells us that the answer is x equals negative 3, x equals 0, and also x equals 3, right? So we have those three answers. However, what kind of equation do we have? We have a fifth degree equation, which means that we could have at most 5 answers. So there's 2 more answers. Now, sometimes we do have answers that have a duplicity, but right here, we need to find those other answers that are likely to be imaginary, okay? Now, how are we going to do that? We're going to take these answers that we got, and I'm going to plug them in with synthetic substitution so I could get a depressed polynomial. You see, an equation of degree 5, that's tough. Even of degree 4 is tough, or degree 3. But once I depress it so far that it becomes a x squared, a quadratic equation, I'll be able to factor it, or I'll be able to use the quadratic formula to get the answers. So our first answer that we have is x equals 3. And I am going to take the answer 3 and plug it right into this box, right? And I need a list of the coefficients starting with the highest degree going all the way down to the smallest. There is no constant, so I don't have to worry about that last number. But anyways, what's the first number? 1. And then the next one? Yeah, the x to the fourth. There is no x to the fourth. How about x to the third? There is no x to the third. There is no x squared, but there is an x. And there is no constant. I don't even need to write it down because there is no number that's being added or subtracted at the very end without a variable. Anyways, we know that an answer, when you plug it in, it should give you the remainder 0 because it's a factor of it if you were to write it in factored form. So what we're going to do here is do synthetic substitution. As you go down, you combine. 1 plus nothing is 1. As you go up, you multiply. 3 times 1 is 3. As you go down, you combine. 0 plus 3 is 3. As you go up, multiply. 3 times 3 is 9. As you go down, combine. 0 plus 9 is 9. As you go up, multiply. 3 times 9 is 27. As you go down, combine. 0 plus 27 is 27. As you go up, multiply. 3 times 27 is 81. And we are at our remainder, and we need that to be 0. It's not a surprise. As a matter of fact, we need it to be 0. If it's not 0, then we know we did something wrong, and these numbers are wrong, which will mess up our depressed polynomial. Okay? So this depressed polynomial is, here's a constant, this is x squared, this is x to the third. It's still a polynomial that I'm not comfortable with. I need to make it smaller so I could get it to be a quadratic. Because once it's a quadratic, maybe I could factor, or at the very least I could use quadratic formula to get my other answers. Yay? All right, so I am going to not even write this. I could write it as x to the third plus 3x squared plus 9x plus 27, but that'd be a waste of time because I'm going to use this list of numbers to plug in my next answer. My next answer was x equals negative 3. Okay, so I already plugged in this guy right there. Now I'm going to plug in the x equals negative 3 right here. And I'm going to use this list of coefficients on my depressed polynomial to keep working with it. So I have the 1, the 3, the 9, and the 27. And once again, as you go down, you combine. 1 plus nothing is 1. As you go up, you multiply. Negative 3 times 1 is negative 3. As you go down, you combine. Negative 3 and positive 3 is 0. As you go up, you multiply. Negative 3 times 0 is 0. As you go down, 9 plus 0 is 9. As you go up, you multiply. Negative 3 times 9 is negative 27. So the remainder is 0. And again, if you don't get 0 right here, you know you did something wrong, so go back and check your work. But now we do have a constant 9. There is no x, but there is an x squared. Now we do have a quadratic equation that we could solve. So this is technically an x squared plus 9. You guys agree with that, yeah? That's a depressed polynomial. Now, if the question was rewrite this in factored form, you could have graphed it the way we did on Desmos, and then you have these two answers, and the answer x equals 3 came from x minus 3. The answer x equals negative 3 came from x equals positive x plus 3. That's where it came from. And of course, you have this one right here. And of course, if you were solving, you would set it equal to 0 and split them all and solve, and you'd get these two answers anyway. Okay, I'm kind of going in a circle right there. I apologize. They're not asking us to factor, so don't do this. All we really need to do is solve this guy right here, okay? So x squared plus 9 equals 0. I need to solve that. Let's do it. X squared plus 9 equals 0. So we subtract 9, we will have x squared equals negative 9. Square root, you'll have x equaling plus or minus 3i. Whenever you do a square root in an equation, you have to put a plus or minus in front of your answer. So what does this mean? I have two answers right here that are imaginary, and I have the other answers, the other three answers that we got on Desmos, positive 3, negative 3, and we also had x equals 0, huh? So that was a total of 5 answers. 1, 2, 3 real, 2 imaginary, total of 5. Make sense? Yeah. Okay. So we will be able to use Desmos. Sometimes it makes it really easy. This wasn't that easy. It still required a lot of work. Sometimes you might prefer to use factoring. So you know what? Let me compare this to factoring this exact equation. So the x to the 5th minus 81x. Let me rewrite it and then apply factoring skills to solve this thing. Remember, it is equal to 0. Wait a minute, that was an 81x, I apologize. And it was equal to 0. What could I factor out of here? The GCF, which is an x, right? If I pull out the x, what will be left on the inside? X to the 4th minus 81. And if you look at the inside, you technically have a difference of 2 perfect square terms. So you could square root, and then plug it into your factored form format. So if we did do that, the square root of x to the 4th is x squared. The square root of 81 is 9. And of course, you'd have to have one being positive and one being negative. It doesn't matter which one's which. And you still have the x that you originally factored out to start with. Now, could you factor anything else? You can't factor this guy, but this guy is a difference of 2 squares again. You could square root, and plug it into your factored form format. So the x squared minus 9, I could technically factor it further and get an x plus 3 and an x minus 3. And of course, we have the x in the front, and we also have the x squared plus 9 at the back. And of course, this is the same thing as this. It's just in factored form. Why would I want it in factored form? Because if it is equal to 0, which it is, we could split them up and solve each of them. So I did use zero product property to split them up, each equal to 0, x equals 0, x minus 3 equals 0, x plus 3 equals 0, and x squared plus 9 equals 0. So we have these 4 simple equations that we could solve. The first one's already done for you. That's an answer. The other one, if you add 3 to both sides, it'll be x equals 3. The other one, subtract 3 to both sides, it'll be x equals negative 3. And the other one, you actually have to do a little bit of work. Subtract 9, you're going to have x squared equaling -9. And of course, at the end, square root, you're going to get x equals plus or minus 3i. And that's another two answers that are imaginary. So you could compare the work we did with Desmos by getting three real answers right from the start and then just plugging them in to get depressed polynomials till we get to a polynomial that's a quadratic that we could actually solve, or factoring. Now sometimes it'll be ridiculously easy by graphing. You'll be able to see all of your answers. So like if you would have graphed this guy and you would actually see 5 different answers on the x-axis, you're done. You don't have to do any math. So it's always great to use Desmos, all right? And it's really cool because you don't have to do what I did in high school. When I was in high school many years ago, talking before the internet, believe it or not, we didn't have Desmos. And graphing calculators were rare and very expensive. So we had to learn the rational zero theorem. And this theorem produces a bunch of numbers that are possible answers. So like if you had like a list that had like a 1, 2, 4, 8, and 16, like you would have to take the 8, plug it in, and see if it actually gives you the remainder 0. But if it didn't, you had to keep guessing and checking. So it was really challenging when I was in high school. You guys, I'm not even going to teach you rational zero theorem because we're going to skip it, because you could just jump right into typing it into Desmos, and for sure you're going to get some answers, right? So check this guy out right here. Example 2, it's on your paper. Let's all go to Desmos and type in that quartic polynomial equation, and let's see if we could find any answers, because the instructions say find the zeros. It's the same thing. Zeros are x-intercepts. They are solutions. So let's try to find those answers. How many answers are we looking for, by the way?
4.
We're looking for 4, right? Okay, let's type it in. Let's see that graph. So if you type it in correctly, you should get this graph. And of course, you might not see all the points. You got to zoom out or zoom in accordingly. And also click on the actual x-intercepts, and it'll give you precise answers. So we know that x equals -4. We know that x equals -1. And we also know x equals 2. Those are 3 real answers, right? How many answers are we looking for? 4. Now, here's a part of the lesson that's very interesting. When we look at the graph, if the graph crosses right through it, then it's just one of these answers, which is -4. But if it's going up and it doesn't cross through, if it only goes up and touches, or if it's coming down and touches, then it's the answer -1, but it technically has a duplicity of 2. Or it could have a duplicity of 4 or 6, but we're just going to say duplicity of 2. So this x equals -1, it's actually repeated in this problem. I'll show you in a little bit. But we're looking for 4 answers. We have 4 answers. The 4 answers are x equals -4, x equals -1, and x equals 2. But on the x equals -1, you could say with duplicity of 2. And that is because it only touched the x-axis. It didn't cross through the x-axis. How could you remember that? Well, this does look like a parabola, and parabolas do have an x squared. So that should help you remember that's like a duplicity of 2. Okay? Let's take a look up at the top right corner of these notes. Before moving up to the top right, I mean, that was beautiful. We didn't have to do any math. You just graphed it, we're done, right? So we love those that have those x-intercepts. Let's move on to the other one. Now, if I would have taught you the rational zero theorem, then I would say, oh, you could use your graphing calculator, but we're just jumping to the graphing calculator. We're just jumping to Desmos. We're not even messing with the rational zero theorem. So if we take a look at this guy, let's graph it. And we're looking for 3 x-intercepts for 3 answers. If it does cross the answer, or the x-axis at 3 locations, then you have all your 3 answers and you're done. You don't have to do any work. But if you see that it only crosses at 1 location, then you're going to have to do more work to find the other answers, which may be imaginary. So if you type it in correctly, x to the third plus 6x plus 20, and again, you could put y equals, you don't have to. Don't put the equal 0, but if you do type this in correctly, you're going to zoom out and you're going to see the whole graph, and you'll see that it only crosses the x-axis right here. And if you click that location, it'll give you the precise location of it, which is x equals -2. X equals -2. Okay, so we want 3 answers, but we only have 1 answer, which is -2. So let's do this. We know that one of those answers is x equals -2. Let's do synthetic substitution and plug in that answer of -2. Let's write a list of our coefficients. The power of 3, the leading coefficient there on x to the third is 1. There is no x squared, so you'd put a 0. And then you have a 6 on the x, and you have a 20 as the constant. And as you go down, you combine. 1 plus nothing is 1. As you go up, you multiply. -2 times 1 is -2. As you go down, you combine. 0 and -2 is -2. As you go up, you multiply. -2 times -2 is +4. As you go down, combine. 6 plus 4 is 10. As you go up, multiply. -2 times 10 is -20. And that's great that we got a 0. If you didn't get a 0, you made a mistake. You got to go back and check your work. But by us plugging in this single answer of x equals -2, I now have a depressed polynomial that's actually a quadratic trinomial. That quadratic trinomial is x squared minus 2x plus 10. And I could actually solve this. If I set it equal to 0, I could solve it. Now, I could try factoring. What times what is 10? That if I add together is -2. But that's not going to work because it's not factorable. But nevertheless, we could use the quadratic equation. Not only that, the graph showed us that it only crossed at one location. So I'm not going to be able to find any other real answers. So they must be imaginary. So I'm going to use the quadratic formula, identifying that my a value is 1, my b value is -2, and my c value is 10. And I'm going to plug that into the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all divided by 2 times a. And when we use the quadratic formula, I recommend plugging in your values with parentheses. So rewrite it with parentheses. And then let's plug in our values. I'm going to start with b. b is -2. So the b of -2 goes right there and right there. The a value of 1 will go down here and up here. And the c value of 10 will go over here. Now, when we use the quadratic formula, let's begin by focusing in on the discriminant value. So what is -2 to the second power? 4, right? And then what is 4 times 1 times 10? 40. So I really have 4 take away 40 inside the square root, which is -36. So what I really have is a +2 plus or minus the square root of -36 over 2. Now, what is the square root of -36? Anybody? 6i. Thank you so much. And now from here, you could split the denominator 2 to each of these and then divide by 2, or you could just reduce all 3 of them by 2, and you'll have your final answer. Reduced by 2, you'll have a 1 right here and a 3 right there. So your final answer is 1 plus or minus 3i. And that is 2 imaginary answers. So this third degree equation, we got 1 real answer and 1 real answer only. We use that 1 answer to get a depressed polynomial, which gives us a quadratic. Then we use the quadratic formula to find our other 2 imaginary answers. So this third degree equation really does have 3 answers. One of them is real. It's actually -2. And the other 2 are imaginary. Sound good? Alrighty. There's still a little more to this lesson, but we're going to not move on to that second part of the lesson, but I do want to go to our actual homework. 5.7 WSP. On this worksheet, they want us to solve, like, what do the instructions say over here? Solve each equation and state the number and type of roots. Like, do you have 3 real answers, 2 imaginary answers? But of course, if you're solving it, you're actually going to have your answers. Or they could ask you like this, find all the zeros. It's the same thing. Finding the zeros, finding the answers, same thing, right? So let's actually, since we're here on number 11, let's actually solve number 11. Okay, how are we going to solve it? Let's type it into Desmos. I really, really hope that when I graph it, I could see that it crosses the x-axis at 3 locations, because those will be my 3 answers and I'll be done. So here it is. I typed it in correctly, and you're going to have to zoom in appropriately. Like where does it cross? You got to zoom in so you could actually find your three locations at -7, at 1.5, and at 4. And this was a third degree equation. We have actually three answers, then we know we're done. That's it, -7, 1.5, and 4. X equals -7, X equals 1.5, and X equals 4. That's it. That's all there is to do. We are done. We love these types of questions. Third degree equation, three answers, we're done. Nothing to do. Let's move on to, let's try number 14. Have you guys graphed it on Desmos? As you're graphing, how many answers do I want? I want 4, right? So what happens when we type this one in? If you type it in correctly, you're going to see that it doesn't cross. Actually, you won't see anything unless you zoom out to like 48, 49, 50. Then you'll barely be able to see this part of the graph. But when we're looking for the answers, we're looking for the x-intercepts, and it does not cross anywhere. So how many answers am I looking for? 4. How many of those 4 answers are real? None. Like there are no real answers, but that doesn't mean that we just say, oh, there are no answers. We know that they're going to be imaginary. If they're not real, they're imaginary. So just because Desmos gives us some answers most of the time doesn't mean that it's always going to solve our problems and we could forget about factoring. Right here, we have to resort to our factoring skills, right? This is a trinomial. I could make it look like a quadratic. Let's do that. I could make it look like something squared plus 50 times that same something plus 49, and I could actually factor it and then solve. But what should belong right here inside the parenthesis in order for it to still be an x to the 4th? X squared.
I mean, x squared. How did I say 2 squared?
Okay. Now, this is where the first time I showed you this, I'm like, well, you could change your x squares temporarily to become a values. You guys remember that? Yeah. But you know what? That's kind of a waste of time. All right, it's kind of a waste of time because let's just pretend that it already says x squared plus 50x plus 49. So if it did say x squared plus 50x plus 49, then you'd be able to factor it like this, and you would put x right here and x right there. But these aren't x's, they're what? They're x squares. Does that make sense? Okay. So, I mean, if you wanted to, you could have substituted a and made it look like a squared plus 50a plus 49. You'd have an a right there, and then you could, what times what is 49 that if you add together is 50? What is that? What times what is 49 that if you add together is 50? 1 times 49, okay? And then you would have to split them and solve. And then you'd have to re-replace x squares back into a's. So if you just do them with x squares, you save yourself a little bit of time. We're still going to split them and solve. We actually have x squared plus 1, set that equal to 0. We also have x squared plus 49, and set that equal to 0, using zero product property. So we're going to subtract 1. You will have x squared equaling -1. And to get rid of a square, we apply a square root. So we have our answer x equals, whenever you apply a square root, you have to put a plus or minus in front of your answer. And this is what? I. Because the square root of -1 is I. I hope you guys remember that. So technically we have 2 imaginary answers right here. Let's solve the other one. Subtract 49. We're going to end up with x squared equaling -49. We're going to apply a square root. And your answer will be x equals plus or minus what? 7i. And that's another 2 imaginary answers. So we really do have 4 answers. X equals positive I, x equals negative I, x equals positive 7i, and x equals negative 7i. And that satisfies this 4th degree equation. 4 answers for a 4th degree equation. Make sense? We could try 14 or 15. We already did 15?
Yeah, and we just did 14.
Oh yeah, so we already did 15?
Yeah, we did it on this one.
So it was on the other one, okay. So you guys want to try 16? I mean, it's up to you. Either way, you're going to type it into Desmos. And so let's type in 16 on Desmos. Hopefully we get 4 x-intercepts, and we're done. Those will be the 4 answers. Or maybe, hopefully, you'll have 2 places where it touches, which would mean that both of those answers would have a duplicity of 2, and that would satisfy your 4 answers, right? But let's see what happens when we actually type it in. If you type it in correctly, you're only going to get 2 x-intercepts, right? And that means that it only gives us 2 real answers. And what are those answers? X equals -2 and x equals +2, right? But we're looking for 4 answers. So let's see what happens. We need to take one of these answers and type it in, or not type it in, but do synthetic substitution. I want to take this guy, put it right in there. You don't change any signs, you just plug it right in because it is an answer. Let's do a list of the leading coefficients. We have 1 on the x to the 4th, a -6 on the x to the 3rd, a +6 on the x squared, a 24 on the x, and a -40 as the constant. So as you go down, you combine. 1 plus nothing is 1. As you go up, you multiply. -2 times 1 is -2. As you go down, combine, you'll get -8. As you go up, multiply, you get +16. 16 plus 6 is 22. As you go up, multiply. -2 times 22 is -44. As you go down, combine, you'll get -20. As you go up, multiply. -2 times -20 is +40. And that is great that we got 0 as a remainder. If you don't get 0 as a remainder, go back and check your work because you did something wrong, which means your depressed polynomial will be wrong, which means everything's going to be wrong. So since we got 0, we're good to go. Now, that's still not a quadratic equation. This is a constant. This is x squared, x to the 3rd. I would rather have a quadratic. So I'm going to keep these same numbers, the 1, the -8, the 22, and the -20. And I'm going to use my other answer, +2. So I'm going to put the +2 right here. And I'm going to do synthetic substitution again. As you come down, you combine. 1 plus nothing is 1. As you go up, multiply. 2 times 1 is 2. So you go down, combine. That's -6. As you go up, multiply. 2 times -6 is -12. As you go down, combine. 22, take away 12. That's -10. No, +10. I'm losing it. As you go up, multiply. 2 times 10 is 20. And it cancels out, and that's great because we did it right. Because if it is an answer, you need to get 0 as a remainder. So this now is a depressed polynomial that we could work with. This is x squared minus 6x plus 10. Wait, did we already do this one? I'm losing my mind. Sorry. Anyway, that is a quadratic trinomial equation that we could solve if we set it equal to 0. So if we set it equal to 0, we could identify the a value is 1, the b value is -6, and the c value is 10, and plug it all into the quadratic formula. And of course, when you use that quadratic formula, use parentheses when you plug in your values. So we're going to plug in the a value of 1 right here and right there. We're going to plug in the b value of -6 right here and right there. We're going to plug in the c value of 10 over here. Now doing the math inside the discriminant, we have -6 squared. So that's a 36. I'm just going to jot it right down on the side right there. And then I have 4 times 1 times 10. That's 40. So I really have 36 take away 40. Isn't that right? And that is inside the square root. So technically, the -6 right here becomes +6 plus or minus the square root of -4, all divided by 2. And the square root of -4 is really what? 2i, that's right. So we really have 6 plus minus 2i over 2. And you could technically reduce all 3 terms by 2, or you could separate the division of 2 on each of them. Either way, you're going to get your final answer, 3 plus or minus 1i. So on this particular problem that we graphed, unfortunately, we only had 2 answers. And we had to plug them in to get a depressed polynomial and depress it so much to make it into a quadratic. Then we could use a quadratic formula to find our other 2 imaginary answers. Now it makes total sense. We have 2 real answers, -2 and +2. we have two imaginary answers, 3 plus I and also 3 minus I. Those are the four answers to this fourth degree equation. So I hope this helps. We could continue working on this worksheet. Of course, the answers are on Google Classroom. So the question was, when do we use the quadratic formula or when do we factor? Well, I always say if you could factor, factor. So right here, like if I were to look at this quadratic trinomial and I could see, like if this would have been, let's say -7, right? If it were x squared minus 6x minus 7, then I'd be like, oh, what times what is -7? That if I add together is -6, that'd be a -7 and 1. I would definitely factor, split and solve. But always try factoring. But right here, you can't factor. When you start thinking, what times what is 10? That if you add together is -6. 1 times 10 doesn't work. 2 times 5 doesn't work. There is no possible combo. So you know it's not factorable. So that's how you know, well, if it's not factorable, you could always fall back on the quadratic formula. So always try to factor first. If you can't factor, then for sure go for the quadratic formula.